So hi, welcome back to Mountain Boys. Going to do something just a little bit different here on the channel tonight, and that's to talk about my main video light that I use, and that is the GVM P80S, or otherwise known as the GVM 80 watt. So it is a COB LED light that operates at 5600K. It doesn't have any fancy controls. All it has on it is just a on-off potentiometer here to adjust the brightness of the light. So what I'm going to go through tonight here is how I did the fan replacement on this light. I've been really happy with the light, but my fan was dead on arrival in this unit, so I wasn't able to use the light at full intensity. I would maybe only be able to go up to about, maybe 60 to 70% intensity with the potentiometer here at about maybe 2 o'clock or so. Anyway, so I had a choice. I could either pay the warranty, not pay the warranty, but pay for shipping to warranty the light and send it back to GVM and be without it entirely, probably for a few weeks, who knows, and I'd still get back with, a light that may have, at least according to the spec for the fan that was in here, a 27 dBA fan in here. So I decided I was going to go a little bit different route and opt for a fan replacement. Now, there was no information about how to do this online, so I had to go ahead and, figure it out as I went. And the first step was to crack open the light, find the power supply, figure out what kind of fan was inside here, what power was being supplied to it and from where on the board, and then I could go ahead and tackle the fan replacement. So the things you're going to need for this do-it-yourself fan replacement here are obviously the light itself. You're going to need some type of 24 volt or 12 volt fan, 3-pin or 2-pin fan. A 4-pin pulse width modulation fan won't work in this light setup. It'll only operate as a 3-pin fan, because this thing doesn't do pulse width modulation to control the fan speed. It's voltage controlled. So when I cracked open the board, I discovered that the fan was being fed around about 29 volts DC. Now, the fan spec that was in here previously, this guy, this is what was in here previously. It was an HSC 24 volt fan, and the spec for this guy, like I said, was 27 dBA, but it also had a max operating voltage of 27 volts. So I think something on the little fan board itself in here probably just got fried because it was overvolted a little bit. So other than the light itself, your replacement fan, and for this one I went with a Noctua Redo 1200 RPM 3-pin fan, and this is their new Redo line, so this would be very similar to their old A8 fans. I think the ULM or something like that. Anyway, so I went for the Redo. It's a $10 fan on Amazon, but the problem was that the board was supplying 29 volts, and this is a 12 volt fan that went in here. So the next important thing I needed with this build was a plan, and that was, how am I going to get the proper operating voltage for the new fan in here? And this is what I came up with. So we have a single pole double throw switch that's wired into the positive side of the power supply that comes from the power board. Then it goes into one of 2 DC to DC converters that can take anywhere, basically anything up to 35 volts DC, and convert that on one half of the circuit down to 9 volts, or on the other half of the circuit down to 12 volts. And here we can see I've just got some decoupling capacitors on the input and output pins of the DC-DC converters, and then it goes into a 3-pin Molex friction fit connector, which the fan connects to, and it connects, positive to positive, ground to ground, and then the yellow wire in here is for the tachometer of the fan, and that's just left open, non-connected, and it works just fine. So for this, I went with a 9-volt step-down voltage on this part of the circuit, because then I could reduce the fan noise even more than operating it at its full 12 volts. But these DC-DC brushless fans don't like to be undervolted too much, so I figured at minimum I would go probably 7, maybe 8 volts to get the fan to operate at a lower speed and actually operate. So this is how I went about it. You could use linear voltage regulators to regulate your voltage down too, or if you're really good at math, you could go ahead and do a resistor voltage divider network to get these things off here. But they get a little tricky to design when you're having to also equate the load that the circuit's carrying. So I wouldn't suggest going that route. You'll probably pull your hair out trying to figure it out. And so this is the cleanest, simplest, most efficient way that I found to go ahead and step down the voltage to what this fan will use. So enough of that. That's my plan. Some of the other tools you'll need are obviously a good Phillips screwdriver, probably a smaller one, medium one, and a large one. You're going to need a voltmeter, some type of multimeter to see what voltage you have coming off the board. You are going to need all the components for the circuit that you want to make to step down your voltage. You're going to need a little bit of bench stock, so you're going to need some type of little, prototyping circuit boards, as well as, some hookup wire. You're going to need some flux and solder, and you're going to need soldering iron, soldering station. And you're going to have to be comfortable, soldering up your own circuit, making your own circuit to do this build. So other than that, I use some needle nose pliers. What else do I have in here? I have some angle cutters. I have some more little brass M2 standoffs and screws that I used for my to mount my circuit board in here. And that's pretty much it. You're just going to have to be comfortable tearing this thing apart and getting into it. Needless to say, when you get into it and everything else like that, you're going to probably void your warranty. So you're going to have to be okay with that too. So let's go ahead and start diving into this light. You can see on the front we have the Bowens mount, we have the LED COB chip itself right here. We have the heatsink mounting bracket or mounting assembly on here for the heatsink. Then on the bottom we have the light stand mount, and it's held in by 4 screws. It's really easy to get off. And then on the back of the light here on the case, we have 4 Phillips screws holding the back of the case on, as well as the power supply retention nut right here and the potentiometer cap. So you can see kind of the final result of my build here. Here's my just little toggle switch. So when it's fully forward, that's the full 12 volts, full 1200 RPM on the fan. Middle position is fan off, and then the back position is 9 volts. And these 2 M2 machine screws here, those just screw into the standoffs that hold my circuit board in place up underneath inside the case. So first step to getting this off. Now, go ahead and grab your needle nose pliers. And if you have a really thin wall 10mm socket, you could use that to get this off also. This is, I'm going for the retaining nut for the power supply right now. So, a pair of needle nose pliers, it comes off pretty easy there. I say that until I actually try to do it. So that's off. You can pop the potentiometer cap off. You might need to grab your pliers again just to give you some advantage. I need a little parts bin. What am I going to do next? I'm going to do the mounts. So 4 Phillips screws, machine screws. They look to be probably M5 machine screws on the back of here. Turn it around. You do want to be careful that you don't touch the LED chip itself with bare hands. If you wanted to, you could probably wear, vinyl gloves or nitrile gloves just to be extra careful. But I find if you have a clean work surface and you're mindful about it, it's not too much of a problem. So once you get all the screws disconnected, you can go ahead and set the stand mount aside. Set that right there, and I can set it straight down on the slip because that LED chip is still protected here. So I'm going to go for the 4 screws on the back. 1, 2, 3, and 4. So once you have those screws all undone, it's just a little bit of a press fit to get it back out. And now you kind of want to slide your thumbs in between the back of the back case cover and the case itself, while you at the same time push up on the handle, because it just slides down into 2 slots on the side, and then the back of the case will come free and the handle will come off just like that. I'm going to collect my back case screws. So now we can start to dive into the board itself a little bit more. Maybe I'll zoom in some on this so you can see it a little bit better. So the PCB that's in there right now, it's held on with 2 screws back to the case cover. So I'll go ahead and disconnect those. Disconnect, unscrew those. And then since I took off the potentiometer cap and the power supply retention nut, the PCB will just come right out of this. So I'm going to set this aside for a second. And you'll notice here on the back of the case, if you can see it, I actually used a Dremel and I took out a lot of material here on the back of the case, because when it was in here, which way did it go? Like that. And that material was inside the case. It was really, really hard for these wires to sit right there. They were having to make some extreme bends and some extreme kinks, and a lot of stress was put on them. So I took that material off the case just so the wires would, be a little bit more free. I'm going to zoom out now. Okay, so once you're into the fan itself, let's look at the PCB here a little bit. So these two white wires on the end, I suspect that these are for a temperature sensor for the LED itself. So if it gets too hot, you know, it has some type of thermistor or something in there that tells it to kill power to the light so it doesn't, you know, fry itself. The middle connector here, this is actually your fan power supply right here, and then this other one right here at the end with the little bit thicker red and black wire, this is your power itself for the LED. So the next step for this would be to disconnect your fan power supply right here. It's this little friction fit 2-pin, I think it's probably like a XH connector. So just carefully disconnect it there, and then you can kind of just set this aside and work for it. Now when you get into your fan the first time, all these wires are going to be bundled together with a zip tie. You'll have to cut that, and as well you can see I removed a little bit more material. Let me zoom in again. Right here there's a little channel at the top of the case that the wires run down. I removed a little bit of material right off the inside edge of this again, just so wire routing, it wouldn't put as much stress on the wires. There was no need to have it in that tight. Now, to get your fan out when you go this far, obviously you won't have the circuit that I made in here to get your fan out. But what you will have are 4 screws on the corners in here that screw into the heatsink. So those are what hold your fan in place. It may be that to do everything you need to do on this light, that you will also have to go in on the front and separate it out a little bit, just to get the wires loose to get your fan free. And on the Bowens mount itself, you have 3 screws, and then underneath on this kind of retention ring for the heatsink, there's another 6 screws. And once you get all those undone, it'll literally just kind of come apart here at the front. So it'll kind of come apart there at the front. You have a little bit of room to work with, and the wires will be literally fished into the back of the heatsink a little bit, and at the front of that wire channel right here, there'll be another zip tie you might need to cut. Also, be mindful if you do end up taking off the Bowens mount here, that it's kind of spring-loaded on this little thing, so don't lose the spring that comes out of that, and pay attention to the orientation of the little set piece in there for your mount, so you know which way it goes back in. So moving on, I'm just going to show you the disassembly here. So on the bottom of the little board that I made, you can see that's where I've connected the fan power, and I'm going to go ahead and take out my circuit. To start with here, I have a little retention nut on my switch with a lock washer underneath it, lock-ing kind of washer. It's one of those fun toothed washers. And you can see here on top that I thought I was going to need more mounting points for my circuit in here. I ended up not using these 2 that I put in. Just 2 standoffs with bolts, plus the switch itself held it more than securely. So go ahead and take off those. I'm going to take off my standoffs here. And now my circuit will just drop free. So I guess briefly we can go through my circuit a little bit. So this is the power supply wire right here. Red is your positive, and then the red and black is your ground. That goes into my switch, and then it's split. Here I have my 9-volt DC-DC converter, and I have my 12-volt DC-DC converters, and I have my decoupling capacitors. Now, I put 2 Molex connectors on here, and that was just because when I was building my circuit and everything, it was more convenient to have to be able to attach my fan power up top rather than on the bottom while I was working on it itself. So these do the same thing. It's just when I have it hooked up actually in the fan, I use the bottom connector there. So, and you can see I used my little M2 brass standoffs to mount my circuit right up inside there. So, putting that aside, I'll go ahead and get the fan out now. And like I said, this is the Noctua, what is it? What is the actual model number of this? The NF-R8 redux-1200. And this thing, you know, at full 12 volts, only produces about 9 dBA of noise on here, which is, you know, even at this is full power, it's putting out 1/3 of the fan noise as the stock fan, at least according to the specs. So 80 millimeter fans. When you take out your fan, they're going to have some M4 bolts that actually won't work with the new fan. They're a little bit too short because the old fan was only 15 millimeters wide and the new fan is 25 millimeters wide. So you're going to have to get some longer machine screws in here to connect it. So mine, I used M4, I think by 35 millimeter machine screws. That's what I used. So once you have those disconnected, you can just gingerly fish out your fan. And this is the part that'll be tricky to do with the old one with those wires. So now we can see down inside the heatsink, and you can see where the temperature sensor wires, or what I suspect are temperature sensor wires, are fished down in there, as well as the light's power supply itself. And here is the mounting points up in the corners for your fan screws. So that, in a nutshell, is the fan itself. I was already a fan of this light. I felt like it was, you know, pretty good bang for the buck for light output for what you paid for the light itself. And I was really happy with how this turned out because now I can run it at full intensity without the light overheating and shutting off on me, which, you know, admittedly it probably should have done from the factory. But I think even if the fan had been working in here, I probably still would have gone for this replacement just to make it a little bit quieter. And I've had actually no problems when I'm running it at 9 volts, so, you know, undervolting it just a little bit. I've had no problems running the light at full intensity with overheating too. So even at 9 volts, this little Noctua fan is still putting out enough airflow to keep the light from overheating. So another thing to notice when you're looking at your fan is that it has some orientation arrows. So it's going to show you the direction of airflow and the direction that it needs to be mounted. Also, the Noctua 1200 redo fan here, the wiring harness here it was about 40 centimeters long initially, and that was way too much wire to have to stuff back in the case. So I cut about half the length off of that, and I went ahead and reconnected the wires here in the middle, and it's worked fine. So I just shortened the wiring harness a little bit. So then reassembly is obviously just the same as what you've done. So make sure you've got the fan oriented properly. Make sure that these wires are kind of more or less fished down into the heatsink there, and just go ahead and gingerly pop the fan back in. What are you hanging up on? Just like that. Go ahead and secure the machine screws in the corners. Okay, those are secured. So I'm going to go ahead and reinstall my circuit here. And another tool that'll help you to lay out however you want to mount your new circuit in here is a set of calipers. Those will kind of come in handy to measure things out and lay out where you need to put your screw holes and things. So go ahead and get that one started. Get this one started. And it's kind of a pain having to work like this and shoot a little video without my main light. Once you get a nice bright light that you can use as a key light, you won't want to go back to having to kind of jury rig a lighting setup with, you know, LED bare bulbs and little dish reflectors bouncing off foam core, etc., etc., to get a little bit of decent light on this. So I'm actually going to be really glad when I can start using this thing full time again and not having to have it in pieces on the workbench. I got that upside down. And grab my pliers, put a little English on the retaining nut here. It doesn't need to be super tight. That's probably good. It's got that little set washer, lock washer, tooth washer, whatever underneath it. So there we go. And I'm going to reconnect fan power back in here. There's my friction fit Molex. Tink, reconnected. Okay. Now, I'm going to reinstall the PCB back here on the case cover with the two itty bitty screws. There we go. And yeah, you'll just have to keep track of what screw goes where, obviously. Do one. Grab the second PCB screw. Oh, I missed a step. I forgot to hook up the fan power supply to the PCB before I reinstalled the PCB. So don't get in too much of a hurry. Again, this just snaps into here. It only fits into the connector one way. Snap, just like that. Now I can reinstall it. There we go. Okay, now the next step, and this is one I like to forget, when you're going to put the back of the case on here, you have to have the handle in there first, and you just barely get it set into those little grooves right there like that. They just slide into those little side channels. So you get that set in, then you kind of fish the case back on top of it, and you can slide that handle all the way in, and then everything, if your wire routing is okay, should be a nice little press fit with a snap, just like that. Now you can go ahead and put on your case cover screws. Oh, I've already got a screw in these two. Wonder why the screw wouldn't go in. There's already a screw there. And the final screw. Now it's time for the potentiometer cap, and for this, just kind of pay attention, maybe do a loose fit on it and check the marking on the potentiometer cap here just to see if it follows the full range and see if it is where you want it. So I'm actually going to put it about there, all the way on. Yeah, I think that's good. I like that. I mean, it's not exact anyway. And then the final thing is the retention nut here on the power supply port. Yeah, and if you have a thin wall 10 mil socket, this will go a lot easier than using a set of needle nose on it here. Can't even see that in the video, can you? There we go. And the final step then would be to just reinstall the light stand mount with the brake control. And those go on the 4 screws. So I'm going to go ahead and cut right now. I'm going to go grab the power supply for the light, and we can do a little demonstration. Okay, so I grabbed the power supply. Here, I'm going to go ahead and plug it into the back. I'm going to turn my fan off for right now, and we can go ahead and kick this thing all the way on. You can see full intensity. This is really a great light. I mean, it's really simple. It doesn't have a lot of extra features that some people may think you need. I mean, it's obviously AC powered. It doesn't have a battery pack component that I know of, unless you want to design and build one of those too. But you'll have to supply 30 volts to it. That'll be kind of a neat trick. It's so simple in its design and operation that it really lends itself to doing a little project like this. As long, like I said, as you're comfortable coming up with a plan of figuring out how you're going to supply the right power to it, the right voltage to it, for the fan that you want to replace it with. Now, I'm going to go ahead and excuse the noise here for a minute. I'm going to disconnect my microphone, and I'm going to stick it right next to the fan. First, I'm going to turn the fan off. So here's with the fan off. Now here it is with 12 volt power. So right now, with the gain settings on my Tascam DR60D Mark II preamp audio recorder, I'm getting right around negative 41 dB of noise from the fan. Scratch that, negative 43 dB. Now I'm going to go turn the fan off. And let's kick it over to 9 volts. So I'm getting negative 46 dB right now on my audio recorder. I mean, not very scientific with my little lav mic stuck about an inch away from the exhaust vents on the fan case, but it gives you a sense. Like literally at 9 volts you cannot hear this thing at all, and even at the full 12 volts it's still really quiet. So I've known many a computer fan and case fan that that are just way louder than this. So there we go. That has been a fan replacement on the GVM 80 watt COB fan, and like I said, I used the Noctua I can never remember this model number, the Noctua NF-R8 redux-1200 fan, and it's having step down voltage from 29 volts or so coming off the PCB down to 12 volts and or 9 volts depending on switch position here to the fan itself. And that's by means of these two DC to DC converters. So like I said, come up with a fan. And also one other thing I might want to mention is they also make the NF-R8 Redo 1800. So it's an 1800 RPM fan. Now that thing requires just a skosh more amperage than the 1200 version. And I think just to be safe, I would stick with the NF-1200 fan on here, or the Redo 1200 fan, instead of stepping up to the 1800 for a couple reasons. One, I wasn't entirely sure how much amperage I could draw off of the PCB in the fan unit itself, so I wanted to keep that as low as possible, and frankly I wanted to keep it at a lower amp draw than the fan that came out of the unit. And if I went to the 1800 fan, it would draw just slightly more amperage off that PCB, and I really wasn't comfortable doing that without knowing what the board could handle. Plus, the 1800 is a little bit noisier anyway. And as you can see, I've got this thing on full intensity right now, and it's operating at 9 volts on the fan, and I could let this thing pretty much go indefinitely, and it'll never overheat on me. So even undervolted and under RPM'd, the 1200 RPM Noctua fan is doing just fine. So this is Mountain Boys. I've had a lot of fun tinkering with this particular project. Another thing you might want to consider when you're doing your circuit design and your circuit layout is, I'll go ahead and shut this off now. When you're looking for your components, I would suggest going to like Mouser or DigiKey, and you're obviously looking for DC-DC converters, or they might call them DC-DC switching converters, or buck converters. And spec'd out here, these can draw 1 amp. That's more than enough amperage that I need. That gives me a wide safety margin. One flaw in my design might be that when I was looking at the data sheet for these DC-DC converters, and for whatever DC-DC converters you're looking at, go into the data sheet, because they will give you, your typical application circuit. So right here, this one typical application is pretty much the heart of the circuit that I built. And they give you the values already for the input and output decoupling capacitors that you'll use. Now you can see here that the 12 volt fan asked for 22 microfarad capacitor that was rated for 25 volts, and that the 9 volt DC-DC converter needed a 16 volt rated capacitor. Now I did that and I followed it to the T, but when this part of the circuit is energized, it's energized clear to here. It's also energized back into the, connected to the this decoupling capacitor also. So really, I probably should have gone with a 25 volt rated capacitor on both of these, just because you want it to be, for safety's sake, probably have double your, anticipated voltage on there. So really, I could have used a 25 volt rated capacitor up here on this one too. I don't think it'll be a problem. I'm not expecting this thing to, to power surge and have any weird power spikes along here. I mean, that's what the decoupling capacitors are for anyway. But that's just something to consider. So if you're going to follow this this circuit that I have here, then you might consider putting a 25 volt rated capacitor on here. And for these, for the input decoupling capacitors, I used ceramic here and here, and then I used polarized tantalum capacitors on the output there. So there we go. I think I'm going to start making some more videos like this on the channel, because I've been on YouTube now doing various things for a little over 2 years now, and I have a lot of fun doing it. I mean, this is why I kind of make YouTube videos, is because I enjoy doing it. I enjoy doing little builds. I enjoy fly tying and just kind of kind of making instructional videos in that regard. And I think it might be helpful if I make a series of videos on what I'm actually using around my little filming space in the basement where I do a lot of my stuff. And this is the first one. So this is what I use as my main key light whenever I need a bright light. You know, I'm using this guy here, the GVM 80 watt, and it's been great. And doing the fan replacement, it's only gotten better because now I can crank up the brightness to max on here. But, you know, as far as, you know, talking about the lights, talking about the audio gear that I've acquired that I use, I mentioned it briefly earlier. You know, I use a Tascam DR60D Mark II as my audio recorder, and that's also shooting out to the camera, so I have a dual system sound setup for there. And, you know, I have a few little inexpensive lav mics and a little mini shotgun mic that I put on the camera sometimes. And as far as the camera goes, right up here, I'm still using the Canon EOS Rebel SL2, and it's only recording at 1080. And I'll tell you what, this little camera has done great. I mean, and in the past 2 years, I've probably spent 3 or 4 times what I spent on the camera in lenses. And so I think I kind of want to start going that route and talking about, you know, beyond just the camera, talk about the lenses that I've acquired and, you know, what I've used those for and things like that. So anyway, let me know in the comments what you thought of this build, and if you'd like to get a little bit of you know, behind the scenes background on what I'm using to film a lot of my stuff with. So this is Mountain Boys, and I'll see you next time.